Let's talk about the energy transitions. A lot of times we'll put a summary slide. This is just the assigned readings and videos, but they're pretty short, so you can go back and get those when you have a chance. All right, let's talk about what do we mean when we're talking about energy, where energy comes from, why we care, and what are some of the fun things that are happening. Okay, so when we say energy, energy can mean a lot of things, but in this class what we're talking about is our energy systems. And this is just kind of a map of what do those energy systems look like. This is what humans care about, right? If you're just thinking about what do we want services, right? We want charging, we want our mobility, we want these kind of things. This is our services. And this is where we should start thinking about our energy systems, because that's what it's all about, is providing these services. And then you can start thinking about, well, I want this service, is there a better way I can provide it? And then we can talk about what better means. It's going to be different for different people. But if you start with services, then we're all on the same page. This is what we're trying to do. These are what are available to us as energy resources. This is what's available on our planet that we can make into services that we want. I put energy efficiency here. We talk about energy efficiency in this class as a resource. If we can provide the service, same or better service, using less energy, that is a resource because it's reducing our reliance on something else, right? So these are what's available to us. Sometimes we can do our direct service, like you can have lighting from sunlight with our resource, but most of the time you're having to do something else to it before you can get your service. And so this is our secondary energy column. And that's where we're talking about electricity is the secondary. It's an energy carrier. It's carrying it from our resource, that energy from our resource to our service, to provide our service. Gasoline is an energy carrier, right? Because we had to take the oil out of the ground, we had to process it to make it into gasoline and do that. Okay, so those are our carriers. And then of course, energy storage comes in as, especially in electricity, because it's a way of being able to store that energy for later use and better able to match when we want to use that energy, when we're demanding it, and when we're able to supply it, right? So that's kind of the energy landscape. We like to think about systems in this class a lot. These are our two largest energy systems in our world today, using oil for transportation, using coal for electricity production. These are the two largest energy systems in the world. And they are pretty inefficient at providing the service that we want. So this is what this is like. You put 100 units of energy resource in, you're only getting 1 to 10 units of energy service out of that system. And so if you think about the impacts, all the different aspects of the impacts of the system, when you're only getting, you know, a 1 to 10% efficiency, that's significant, especially given the scale of these systems. And so that's a lot of what we're going to talk about. Now with these systems in particular, some of the biggest losses that you see in these systems are where we're converting heat to work. When we're taking heat and converting it to work, that's a heat engine, that is a very inefficient process. So in this system, that's our power station. 2/3 of your energy is lost here. You're only getting 1/3 of the energy from your coal out of your power station. That's a lot of loss, right? In your oil system, it's really at your car. That is a heat engine. We can only do it so efficiently. We can only get so efficient at converting heat to work. And so we're going to talk about that in terms of like, what can we do better? How can we improve the efficiency? How can we make these systems better or transform them entirely so we don't have the losses that are associated also with all of the impacts that come from using these systems. So fossil fuels are where we are. I mentioned this earlier. In terms of our energy systems, our commercial energy that we're using in the world today, dominated by fossil fuels, right? Coal, oil, and natural gas as our fossil fuels. Our percentages are coming down, but our totals are going up as energy needs go up, as population goes up. Electricity is a subset of that. So this is total commercial energy. This is a subset, it's just the electricity production. Again, dominated by fossil fuels, but less so. A lot of our other resources, our renewables, things like that, are pretty much only electricity, right? So they're a little bit bigger portion of our electricity systems. You can see the other big thing that changes is oil is really a transportation thing. It's not used a whole lot in our electricity systems unless you're in places like islands that don't have other resources. Okay, so it's a pretty small piece of this. I keep saying commercial because one of the things I want to be clear about A lot of times this data and the things that we'll look at does not include traditional biomass. Traditional biomass is biomass that people collect for themselves. So that's wood, that's animal dung, things like that. It is not well tracked because it's not bought and sold. When you buy something, you tend to track it pretty well because you want to know how much you're getting for your money, right? It is not well tracked. It is estimated. There's a lot of effort to reduce people's reliance on traditional biomass and move them to more modern forms of energy because it is significant, especially in the low end for human development. And we'll talk a lot more about that. So that's where we are today. I like to look both at where we are today and where we've been historically. So this is what our energy system has looked like, since 1800. For a while, we were really wood dependent. We discovered coal and quickly transitioned a lot of our energy demand to coal. Some studies have shown that really saved some of the forests in Europe because they started to use coal instead of clear cutting all of the forests. And then we discovered oil and gas. Oil especially, that was definitely the first transition we made when we discovered oil was to use it for lighting, which we were using whale oil for lighting at the time. And so that was a significant transition because whales were becoming scarce as a lighting resource. And so oil quickly and kerosene quickly reduced our whaling industry when we first discovered oil and gas. So those are significant energy transitions at the time, had positive environmental impacts, I would argue. And then, of course, now we're very much oil, gas, and coal age with those little wedges of renewables. And we need to get here because this is now damaging, has been damaging our planet in other ways, as we're going to talk about more in this class, right? And so that's kind of the landscape of where we're at. All right, so that's where we are. Those are our energy systems and how we're using them. Let's talk about why we care and why you guys are here and why we're here talking about energy. So these are just kind of different categories of why we care about energy, and I'm going to give some examples of each of these. So I talked about economics, political, environmental, ethical, health. These are all reasons that we care about energy. So let's start with an economic one. Social costs equals private costs plus externalities. Private costs are what consumers are paying, like that would be what you're paying at the pump, gasoline. Externalities are the things that are borne by society, so costs that aren't included in those private costs, right? And that gives you your social costs. So it's just a way of thinking about who is paying and what are the impacts of different things. So the cartoon I have is from your example in looking at gasoline. Kind of love this cartoon. This is a different way of thinking about externalities, but that's your private cost. You're right, you're paying 3 something, I don't know, 4 something now. I don't know, at the gas station per gallon. But then there is the money that goes into protecting our access to that oil that is providing that gasoline. So that's the military costs, and so the social cost is all of that. It's just an example, okay? So this is one of the reasons we care about energy is because of the distortions. And policy is really one of the ways to try to incorporate those externalities into the private costs, or that's government that bears the costs of social costs for society, right? And so we see both of those things going on. So some externalities from the oil example. These are some of the externalities. I was actually listening to somebody on NPR that was talking about how oil companies are really backing out of a lot of their commitment to net zero, to renewables, things like that. And the person, the oil industry expert they were talking to was talking about it was because governments weren't willing to invest into the expensive, costly, clean energy transition that needed to happen. And so oil and gas companies had to go back to their bread and butter. I would argue that oil and companies actually have a lot of subsidies, and we can go through the different subsidies. So I was getting, I was reacting to the fact that it was this costly energy transition where there was not an acknowledgement that even the emission of greenhouse gases from our oil and gas industry is in sense a subsidy, because that is a cost that's being borne by society that doesn't get included in the cost of oil and gas exploration and and sail. So policy is there to try to incorporate these externalities, right? But there's a lot of different goals with policy. So sometimes we're incorporating those externalities and sometimes we're actually subsidizing it in the other way. And so I list some of those things here. You know, we have gasoline tax. If we had a carbon tax, that would be a way to get that externality for climate change. But we also subsidize the oil and gas industry, especially domestically, because we worry about energy security. And so we want to get the oil here rather than somewhere else. And so there are competing subsidies in terms of the system. Okay, so anyway, that's one of our examples, and we'll talk more about that as we get into fossil fuels. Another oil example for geopolitics is in terms of it complicating foreign policy and trade. Canada is where we import the most oil from by far. And we're, you know, of course, we're layering tariffs on Canada right now, so we'll see what happens. But that's 2024. And for a long time, it's been our largest importer. Not necessarily the ones we hear about the most, right? We hear a lot about some of the Middle Eastern countries, OPEC. We'll talk more about that in terms of geopolitics. But our largest country is Canada. And you can see that, you know, in the United States, we're the #1 oil producer. We're the #1 oil consumer in the world. It's the same picture for natural gas. And for a long time, we were very dependent on imports. We're going to talk about the horizontal drilling, hydraulic fracturing revolution that really boosted domestic production of oil and gas and all of the impacts of that. And so how much we import, we're only importing about 1/3 of the oil that we need when, you know, a decade and a half ago, it was more like 2/3. And so that has impacts on our geopolitics. All right, so Canada being the #1 supplier. I mean, I think we're still friendly with Canada right now, maybe. But what's a trade-off? What is the oil like in Canada? Can anybody tell me about Canadian oil? Yes, so a lot of the oil in Canada is something called tar sands, or they like to say oil sands. It is a very thick bitumen oil, which means you have to heat it in order to get it out and separate it from the sand. It is a very energy and land-intensive process because unlike where you have really, you know, good oil underground where you're drilling for it, what they have to do in Canada is they have to clear cut the land, and they're basically doing strip mining in order to dig the oil out with the sands and then use a lot of natural gas usually to heat up that oil, to separate it from the sand, and then it's a very thick, tarry oil that we have to do a lot of processing with in order to get it into the fuels that we want. Very energy intensive, very carbon intensive type of oil. And so we'll talk more about that as we get into oil. So geopolitics is one part, the environmental aspects is another part of where we're getting our oil from. Natural gas, I would say, just as another example for geopolitics, has been kind of on the forefront in the last 5 years or so. This is showing the share of European Union gas that is supplied by Russia. And you can see that for a long time it was about 30%. It grew to over 40%. And then with Russia's invasion of Ukraine, there was a lot of attention put on it. And you can see that the amount of gas that is of Europe's demand that is being supplied by Russia has declined rapidly. This was not the first time that this kind of conflict had happened in terms of thinking about policy and geopolitics and need for energy. Europe uses a lot of natural gas for home heating, especially in the winter. So it's been very important for that in addition to electricity production. And they did a lot of, I'll just put this up. They did a lot of focus on fuel switching, so switching to heat pumps for homes. So you have electricity providing the heat. That gives you a diversity of fuels. You're not just dependent on one fuel for your heating needs. And imports from other countries. So the United States is now the largest exporter of liquefied natural gas. And much of that is going to Europe because of this conflict. Right? So we care about our energy systems because of the impact on services and the impact on people and the policies. All right, another reason we care about energy. Global energy production or consumption is highly inequitable. And this matters because consumption of those modern sources of energy really impact human development, right? And so this is to give you a sense of the United States here. We are 4% of the population. We use 15% of the energy. We've been an big energy user for a long time. China's had a lot of growth, but of course they also have a lot of people in terms of their energy demand. And you can see places like Europe kind of on the same scale. And then Africa, where it's still very much energy starved in terms of modern energy access, right, in terms of their population. And just to give you a way of thinking about that, or way of looking at how does energy impact human development. What I'm showing you here is electricity consumption per capita. We think of electricity as a modern source of, or modern service of energy, right? It can provide a lot of different services. So electricity consumption per capita versus the Human Development Index. And I just put this little chart up here. If you're not familiar with the HDI, it's really a measure of your health, your knowledge, and your standard of living. So it's an index that kind of gives that. And so what I want you to get from this chart is on the low end, where we're really low on Human Development Index, moving up a little bit and having a little bit more access to that electricity can really increase your HDI index. So on the low end, when we're talking about the developing countries, access to this modern form of energy can be really important. When you get up to a pretty high Human Development Index, you can see there's a big spread of electricity consumption per capita. You can see it doesn't necessarily change your HDI anymore. It's not like we could be more efficient with these systems and still have a very high HDI. Okay, so it's just an example of how important the access to these energy systems can really be. All right, let's talk about the environmental impacts of our energy systems. And so again, we like to think about it in systems all the way from the resource or extraction of the resource all the way to the end use. So we're going to talk about each of these steps as we go through each resource. But there's environmental and social impacts on each layer of your energy system. So obviously, I'm just going to go through these. There's land, there's water impacts, atmosphere, air pollution, and of course, climate change, habitat destruction, health and safety impacts for humans, annoyance, which comes up especially when you start talking about policy, visual noise, traffic. There are intergenerational problems. Climate change is one we're going to talk a lot about, but of course, we're also going to talk about nuclear waste. That's another big one that is from our energy systems. And then there's also energy equity challenges with our energy systems. Who's bearing the burden of the energy systems and who's getting the benefit from the energy system? And so oftentimes our less affluent populations are the ones that are bearing the burden of the benefits that other populations are receiving. So one example of that, I did a lot of my work in air pollution, so I could talk about air pollution forever. But air pollution is actually a pretty significant global problem. So it causes premature mortality for about 7 million people each year. Much of that is indoor air pollution, but there is also about 3 million of that that's outdoor air pollution. Just to put that in context, that's about the same amount of people that died from COVID overall, over the course of the disease. And so that's annually, that's total COVID. Even in the United States, estimates are around 100,000 people dying every year prematurely from air pollution exposure. And that air pollution exposure, we also find it makes people more susceptible to other diseases. So communities that were already heavily burdened by air pollution saw higher incidence of significant impacts from something like COVID, which is a respiratory disease, because you already have weakened systems from the air pollution. So when we're talking about the equity, there was a study done in Harvard that really looked at some of the different communities, who is emitting the air pollution, in other words, who's getting the benefit, and who's being impacted by the air pollution. And so there's definitely, we care about our energy systems because we need to do this better, right? There's definitely an energy equity and an environmental justice part of our energy systems that we need to be thinking about as we're transitioning. Final thing I want to talk about on why we care, climate change. Energy is the largest piece of the pie when we're talking about impacts from climate change. And so this is looking at greenhouse gas emissions that are contributing to climate change. So energy is 75%. We also have secondary pollutants that are contributing to climate change, like ozone, that are from our energy system. So they're not directly emitted, but they're also contributing to climate change. So energy is where the problems are. It's where we got to focus our solutions. You guys know a lot of this, but of course, 2024, warmest year on record, breaking the record of 2023, which was the warmest year on record. We've almost seen a step change in where our annual air surface temperatures are, and certainly a worrying one in terms of our global sea temperatures. So it is an urgent problem that is already impacting people and communities around the world. These are just some examples. We see it with heat waves, with fires, with hurricanes, the big fires a couple years ago in Canada, which were kind of unprecedented, that brought a lot of air pollution to the East Coast. Right? So big challenges. We know where we need to be, right? We need to be at 0 or below. We need to be net negative on climate, on greenhouse gas emissions. It's just a question of when and how fast we'll get there and what are the impacts that we're going to see from it. Okay, but we don't want to end with just talking about the problems and why we care. We want to talk about the solutions and the transitions, and there's cool things happening, and there are cool things that we can keep doing to make those transitions happen. So this was just one study. This is Pitch Book Race to Zero that was thinking about what is the investment that's needed in these different sectors to do the energy transitions that we need in all these different sectors. Okay, and so the interesting thing I think about these different sectors is in some of them, it is really just an implementation challenge. We're not really at a point where we're trying to figure out how do we produce electricity in a zero carbon way or in a way that it reduces environmental impacts. We know how to do that. We can do wind, we can do solar, we can do geothermal, do nuclear. We have a suite of solutions. So this is really an implementation challenge. Transportation, we have a lot of solutions for personal vehicles and light duty. We're still trying to figure out airplanes. We're still trying to figure out heavy duty. What is going to be the clean energy solutions there? So this is like a split. Some of it's implementation, some of it is actually innovation challenges. Buildings, we know how to do a lot more efficiently than we do. So this is, again, an implementation challenge. Industry is a little mix. Some of it we have implementation, some of it is truly a how do we make steel without coal kind of challenge. We know we can do electricity for part of it. Doing the other part with hydrogen is a little bit more challenging. There's still solutions there. So some of it is just about how do we set up the systems to do the implementation. Some of it is still the innovation that needs to happen. And if you're interested in entrepreneurship, I highly recommend Stanford Climate Ventures as a class. Jane Woodward also teaches that. In the fall, they kind of do like a seminar series. In the winter and spring, you're actually in a group and you're working on solutions to problems. And I know a lot of people that have launched companies out of that class. So if you're interested in entrepreneurship and climate, I highly recommend you check that out. Okay, so this is what they said. They're saying, I don't know, we need like $3 trillion a year if it was even, right? $32 trillion over the next 10 years, over the next decade. Where are we at? Well, we spent $2 trillion in 2024 on clean energy transitions, so we're still pretty far from where we need to be if we're going to make that decadal transition, right? So it's not that investments aren't happening, it's the pace, how fast, and where are we going to get with those investments. Okay, final few things I want to talk about are, like I said, some of the solutions. And so here I'm showing you our US energy system, thinking about, again, our resources to our services, right? So our services are divided up into different categories. Those are our resources. Gives you a sense of where things are going and how efficiently are they being used. So oil, transportation, even this part of oil that's going to industry is mostly for making fuels for transportation. So just think oil, transportation, right? Coal is electricity. And you can see how inefficiently we're making electricity. So most of that's going into that gray rejected efficiency. And then natural gas is like our diverse our diverse fossil fuel. It's used for electricity. It's used directly for water heating, space heating, that kind of stuff. It's used as a feedstock for industry, mostly for heating. So it's used in all the different categories. But to give you a sense of like, this is our system, the overall energy efficiency of our economy is only about a third, right? So 34% efficient. Most of it is just lost to the atmosphere, right? And our energy transitions that we're doing. Yeah, question.
Can 100% efficiency ever be achieved?
Yeah, no, that's a great question. And the answer is no, we can't be 100% efficient. Every time we do an energy transformation from one form to another, we have losses. So if that's from chemical to electricity or from heat to electricity, or any time you change forms, you have losses. Efficiency is just one way of thinking about it. As I mentioned, our heat engines are very inefficient. And that efficiency matters because of the impacts of using our fossil fuels or whatever to burn something to do that. If it was inefficient, but yet we didn't have like greenhouse gas emissions or we didn't have coal ash or something like that, we wouldn't worry about the efficiency as much. So it's more like the efficiency matters because there are impacts in the energy resources we're using. So the counterexample to that, anybody know how efficient a solar panel is? At converting sunlight into electricity? Yeah, in the back. About 20%. About 20%. Solar panels are only about 20% efficient. But if we want to think about the impacts of that efficiency, there's two things. It's the amount of materials that you need for the solar panels, right? And it's the amount of area you need for the electricity conversion, right? It's not the same level or the same, it's different, I guess, impacts because of that relatively low efficiency. You can only get up to about 33.5% on a single cell solar panel, even if everything was ideal. And so we have to think about efficiency as just one way of looking at it, but we also have to think about all the impacts and what are the ways that we get the energy services we need. Great question. Thank you for that. Okay, but if we were talking about efficiency, because I like to talk about efficiency, the way I think about efficiency is if we can get the same service using less energy, then that's a win. If we need a lighting service and we're able to use sunlight instead of like an artificial light, that's a win, right? I'm still getting the service. That's what energy efficiency is about. Okay, so the example I like to give, you'll see me every day. I have my little tea container. It's highly insulated. This keeps my tea hot, I don't know, like 12 hours or something like that. I also have, and I don't have it with me today, I also have, if you've ever seen these, there's like electric with battery charged, and you can set your temperature on your little tea container, right? And you can say, I want it this degrees, and you actually have to charge it every day. Keeps my tea hot maybe 2 hours, right? Because it's not very insulated. It's relying on a battery. It's actually providing a worse service and using electricity to do so. Whereas this is just using a vacuum sealed insulation, right? So that's what we have to think about when we talk about services. Let's get it back to services. How can we provide those services in ways that use less energy? Amory Levins is a leader in this space. This is the map that he came up with. So that blue line is what the government said, oh, we're gonna have to grow all our energy needs. We're gonna have to, this is the path they were predicting in terms of our energy demand going forward. And Amory Levins, which was very controversial at the time, said, no, we're gonna get better at it. We're gonna do this black line. We're not gonna do that. That doesn't make any sense. It would get more expensive. It would get more damaging. We're just gonna figure out how to do better. This red line is actually what we did, right? And so some of that is efficiency, some of that is offshoring, some of that are different things. But efficiency is a way that we can get the services we need and hopefully have less impacts. There was also a study done by McKinsey that's pretty famous. This is a greenhouse gas abatement curve. The details aren't important, but what you need to know is over here, the stuff that's below the line means that it's net positive in terms of cost, right? So you're getting money back. And most of these are efficiency measures. So you're not only saving energy, you're saving money. The challenge is that, and this is a quote by another leader in the energy efficiency space, Skill Masters, who used to teach here, it's not $20, it's 2,000 pennies. It's a challenge to implement a lot of these energy efficiency measures because they're dispersed. And sometimes the person that benefits isn't the same person that has to pay for the changes. And so there's a lot of challenges with implementation for energy efficiency. Okay, the next trend that's going on that's kind of one of the big energy transitions that's happening, maybe you've heard of it, is electrify everything. Electrify everything, why? Why do we want to electrify everything? So I just put this list up here and I was just thinking about it. Why do we want to electrify everything? One is oftentimes if you're providing the same service with electricity, it is automatically more efficient than its fossil fuel counterpart. We see that with cars. With an EV is 3 to 4 times more efficient than a gas car because you're not using that heat engine. You're using a motor. They're pretty efficient transitions in terms of converting from your electricity to your motive power, to your mechanical energy. Okay, so proves efficiency, and we'll see that with heat pumps as well. You diversify your resources. So if you're worried about energy security, you can often have domestic sources of your energy resource if you're providing it with electricity. It's easier to decarbonize because you kind of in a line with 2 because you have a lot of low carbon options depending on what resources are available to you. So if we're converting from a fossil fuel, like if we're doing water heating with natural gas and we convert it to water heating with a heat pump, you're getting the same service, but now you can do it from wind, solar, geothermal, nuclear, you can do it from whatever, instead of being beholden to the natural gas, right? So we can decarbonize. Your fuel tends to get cleaner over time. As we clean up our electricity system, then the electricity you're providing to your application also gets cleaner. And we see the opposite often with fossil fuels, because the fossil fuels we have to go get are often harder to get, always, but can be harder to get or more energy intensive. So those fuels tend to get dirtier over time. And then just thinking about in terms of our systems, if we convert everything to electricity, we're maintaining one system. And so if you're thinking like a utility like PG&E, they can maintain 2 systems right now, right? They have an electricity system and a gas system. But if all of our services were provided by electricity, we'd only be investing in maintaining one system. So there is this big push, I would say, to this electrify everything. And so electricity share of our services is going up. Some of that is just providing it to places that don't have it. But even quicker, we're decarbonizing that electricity system. Okay, so this would allow us even more integration of our electricity system, our buildings, our vehicles. And as I said, heat pumps are one of those big things too. So a heat pump, if you're converting from your natural gas furnace, which might be pretty efficient, but still pretty carbon intensive, right? It's efficient, but it has those carbon emissions. Heat pumps, 300 to 400% efficient. I often get people be like, you can't be over 100% efficient. That doesn't make any sense, right? It's because the difference is that heat pumps, and we'll talk more about this when we get to buildings, heat pumps move heat. They don't create it. And so you can actually use less electricity in than the amount of heat you're moving. And that's how that they become this magical 300 to 400% efficient. Because they're moving heat with the electricity, they're not creating it. You're moving heat from the cold space to the hot space. So it can be pretty efficient. And then, of course, you're diversifying the amount of fuels, hopefully decarbonizing your fuels. So I mentioned that Europe kind of turned to heat pumps. Certainly, this is just showing the annual growth in sales in heat pumps in 2021 and 2022. And you can see with Europe, there was a huge growth in heat pumps as converting from natural gas to electricity for heating services. We are seeing growth in the United States as well. Those same 2 years were the first times heat pump sales actually were higher than more traditional gas furnace sales. So that electrification is happening in some places. Transportation, I could talk about transportation all the time. I often get asked, yes, okay, so I get it. Your electric vehicle is charged by electricity, but that's just it's zero emissions at the car. But what about all the upstream stuff? How does that compare? This is looking at our national average grid. So this is our national grid in the United States electricity, and how the carbon intensity per different type of vehicle compares for the national grid. This is going to be different, right? So our electric vehicles come in pretty good compared to our hybrid and gasoline. You can go look at West Virginia. This website is really kind of fun. You can go look at whatever state you're interested in, see how different types of cars compare in terms of carbon intensity. Places like West Virginia, it's almost a 100% coal-powered electricity grid. And in that place, you will see that the electric and the hybrid are about the same in terms of carbon intensity. But I would still say that that car is going to be on the road for 2 decades, maybe. It depends on how long people keep cars. And the idea is that you would still be greening that electricity system. The fuel would get greener over time. So in addition to the efficiency gains you get from the car, you can continue to clean up the fuel as the car is on the road. So that's kind of the magic there. The electric vehicles, I'm sure you've heard a lot in the news about like electric vehicle space was growing, and then is it declining? And then of course, this whole thing with Tesla and Elon Musk and Doge and like all of that thing. I mean, Tesla sales are declining rapidly. So this data is the latest data I have so it's for 2023. It'll be interesting to see how 2025 shapes up in particular. China is the biggest electric vehicle market. In 2023, 1 in 5 cars sold was electric vehicles. China's companies, especially like BYD, are really making strides in terms of market space. And so as Tesla goes down, I would expect BYD to really take on even more market share in the electric vehicle space. So a lot changing, I would say, in this part. It's not the only thing we can electrify. Trains are actually the one transportation that is really significantly electrified. So a lot of the train systems in Europe and in Japan and in China, they're electric trains. We finally locally have electrification of Caltrain, which I'm really excited about. If you haven't taken it, it's like night and day difference between the old diesel hybrids and actually taking more like a light rail electric train. So I recommend you check that out. Kind of my favorite mode of getting to campus. And then the other aspect we have to think about, okay, if we're electrifying everything, that's great. We have efficiency gains, but we have to be able to supply that electricity. So now we're not talking about a replacement place where we're replacing coal-fired power plants with wind and solar, which is where we've been because our electricity demand in the United States had plateaued. It really stopped growing. Well, now we're expecting to see growth. And so not only do we have to replace, we have to grow. And there's backlogs, and there's challenges with transmission, and there's all sorts of things with the grid and trying to grow our electricity production in the United States and elsewhere. And so with Electrify Everything, with AI and data centers, with manufacturing coming onshore, this is going to be a huge challenge of meeting the electricity demands in a clean way. So this is just showing, there's all sorts of estimates, but data centers are going to drive electricity demand. This is just one estimate you can go look at. We have to keep decarbonizing at the same time. It's happening. We're investing in it. We're seeing it, right? I mentioned when I took this class, coal was dominant, right? Coal is now, 15% of our electricity grid. We're seeing wind and solar come up. Nuclear is staying steady. Natural gas has grown a lot, which we'll talk about. So we'll expect those transitions to continue to happen. But we've got to green the grid as we grow the grid. And so that's going to be kind of the new challenge in the next 5 to 10 years is how do we do both things at the same time instead of just replacement. And then batteries. Batteries are exciting. They're not the biggest way we store electricity right now, but there's a lot of potential for batteries. It's definitely a growing area. And I mentioned that wind and solar are the cheapest, but now even wind plus batteries or solar plus battery can come in cheaper than existing coal and nuclear. And so that market paradigm is really driving not just the wind and solar, but storage options as well. Geothermal is a resource that is coming on quickly. Hydrogen's getting a lot of attention, so we'll talk more about geothermal and hydrogen. Fusion, which we'll go on a field trip to learn more about. Carbon capture and storage, which is seen at least as a small portion of the solution. All of these are transitions that are happening, and we'll learn more about this quarter. Thank you guys all for your attention.